Hello everyone, welcome back. This is our lecture 6. In this lecture, I'm going to be covering about the floor and the ceiling method. It's, the method itself is seal, but it's a ceiling method. And then random number generation and the basics of how you go about looping in C++. So quite a bit to cover, but these are all very interesting topic. Very basic once again, but you'll be using them forever, not just in this programming language, but in other programming languages as well. So let me just start off by talking about the floor and the ceiling method. So in order to use those two methods, you should include the library called CMath. And as the word suggests, it's got C in there. It's based off of the C language because we always said, right, that C++ is built on top of C. So itself is a C library, and then C++ is using it. You can use any of the C libraries that you want that's available of use, and then C++ libraries as well. Um, okay, so that's how you start off with. And the floor method is, it's got um, that word in there, floor. Don't worry about the uppercase right now. I'll show you what the exact case is. I believe both of them are lowercase, but I've got an example. So the floor method, all it does is takes a number and goes lower, okay? Takes the floor of a double, let's say for example. So if you get a number 1.9 and you say floor of 1.9, well, floor of 1.9 is going to be 1. Whereas if you say the ceiling of 1.9, ceiling takes the top. So it's going to be um, 2 in that case, okay? Um, this is built-in method, and I'll show you an example of this. Uh, maybe my putty. Okay, this is what the method looks like. So I've got include IO stream for my basic input and output um, scenes and cout. And then I have CMath, right? As I said, using namespace std, beginning of main, end of main, and I've got two doubles. I've got two double number. One is 1.02, blah, 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 and then a number two, which is 2.9. Now, what I'm saying is I want to output the floor of number one. So remember we said that the floor of one point something, it would take the lower number, right? So you're rounding down. So you go to 1. So the floor of this one, floor of number 1 should be 1. And then when it comes to number 2, the ceiling of number 2, so seal number 2 of 2.9 ought to be 3. Okay? And in the slide I had F uppercase, C uppercase, but it's actually lowercase. So the word floor, and then it takes in one argument, one parameter, uh, just one. It could be an int, it could be a double, etc. Okay, so now let me, oh, my putty session's frozen. Of course I want to do this. Now come in, then go to downloads. Takes a second. It's always slow. Okay, we are back. VI floor. So that let me just go ahead and run cpp floor dot cpp. Okay. Now remember what we said. We were looking for the floor of 1 point something and a ceiling of 2.9. I'll run it. Oh, I've got a typo here, but never mind that. The floor of 1.02 is 1 and the ceiling of 2.9 is 3. Okay? Now, so that should be clear. Hopefully you guys understand it. Now think of it this way. If I were to have just integers, what's going to happen? If I say floor of 1 or floor of 2, right? It should still be that same integer number because you've got nothing after the decimal point, so you have nothing to floor it or seal it against, if that makes sense. So let me show you here. Okay, I'm gonna take out the decimal value. I'm just gonna call it integer. Okay, and see what happens. Int. Oh, this is good. What do you think's gonna happen if I say this? Float. Let me fix this. So I'm calling int1, that int2 this, and do this. It's giving me a warning, right? It's not a compilation error, but it's saying that I'm converting 1.02 to 1, and I'm converting 2.8999 to 2. Okay? As just so what's going to happen is my integer is going to become 1, number 1 becomes 1, number 2 becomes 2. And if I were to do floor.out, right? The floor of 1 is 1, ceiling of 2 is 2. I mean, that's essentially the same thing as if I were to do this. If the warnings are throwing you off, that was just to illustrate that you can do that sort of conversion. We make it clear. So get rid of the warnings here. Insert. Okay, let me backspace this, backspace this, and then I've got escape. Okay, cpp floor dot cpp dot floor dot out. Okay, floor of 1 is 1, ceiling of 2 is 2. So you've got integers. There's nothing to floor or seal it against because it's just a whole number, if that makes sense. Okay. Um. All right. So that is for the floor method. What's up next? Floor and ceiling. Hopefully it makes sense. If not, then email me your questions and I'll answer it. The next topic is the random number generation. Now, this is another important concept. Yeah, oh, I've got a typo here. This should be lowercase r. Um, because typically these methods they have lowercase, like you saw the floor and ceiling. Oops, excuse me. So three things I want to talk about in the random number generation: randmax, rand, and srand. Um, so as the word suggests, you come across situations or when you're writing programs, you need to generate a random number. When you need to do that, you are going to use two methods, rand, rand, and srand. And what is rand max? Rand max, depending on the system that you're on, it is the maximum number. It's a very high number that so it can go up to that much. So when you try to generate a random number, chances are it's going to be between 0 and rand max. And like I said, if you try this out in different systems, you should get a different output. But nonetheless, it's a very large number, and for practical purposes, it's going to be enough for you to get that range between 0 and rand max. And think of it this way: let's say if you're trying to roll a dice, you want to write a program that rolls a dice. You want to generate between what is it, 1 to 6, right? So that can come in handy. So the so let me try to illustrate this. Um, the first one, rand. How do you go about using the rand method? And for that, what I have is this. I'm using the method rand, and you can ignore the type of compiler I'm using here. I'm just using an online compiler because it was honestly it was fairly quick for me to type it all up in here in different windows. But you can use your PuTTY session; it's completely fine. So once again, include IOStream. And when it comes to the rand method, the library that we're including is ctime, right? In the previous floor and ceiling, it was cmath. This one is ctime. You can probably guess it by now. Once again, it's based on its parent language, C. So we're using that, and we will learn about this looping structure uh, in a few minutes later on in the lecture. But all this is a for loop that goes from 0 till 5. So I'm going to loop 5 times, and every time I loop through, I output a random number. Okay, let me go ahead and run it. So 5 random numbers you ought to see. 1, 2, 3, 4, 5. Okay, great. I'll run it again. And I'll run it again. I don't know if you caught it, but this right away presents a problem. Hey, you were saying I want to generate a number 5 times, but every time I'm running the program, I'm getting the same result. 180 something 846 168 blah blah blah. Right? No matter how many times I'm gonna run it, I'm getting the same number. Well, that's not really a random number. What's going on? And right, that doesn't make sense. So you're gonna have your program output these random numbers. It's not really random if you're getting the same numbers. So in order to deal with this problem, there is that the other method that I was talking about is the SRAND. Now, what SRAND method does it gives you the ability to seed, or if you for to seed a random number. Um, so essentially, what you're doing is this might to avoid the confusion, you call SRAND and you feed it a starting number. So you can say, look, SRAND is going to start from 0, 1, 2, 3, whatever that is. So you try to get a truly random number every time you generate. Okay, so I had a problem. I'm going to go to the next program. Here, this is how I'm using SRAND. I say SRAND and I give it time null. So as time is always progressing, right now, it might be 8:30 a.m. for you, or whatever the time is. Next time you run it, it's 8:24, 5, so on and so forth. Time is always moving forward. So that's why I'm seeding or I'm feeding srand with the time argument. And this is the exact syntax as it stands. Okay, it's srand, time, and null. So you give it a time, a current time. It's going to give it a current time and then feed it to rand. Okay, and now when I run this, when I feed this to rand, I've given it. Now I try to run this program. I should get a different number every time I run it. One, I'm gonna run it again. It's different. Ooh, still different. Keep running it as many times as you want. You're always going to get a different random number because we fed the random number generation with the time argument. I said this is the current time. So that's how we resolve the issue of the rand or the random number generation. So this is how we're able to truly get a random number. Now, let me do this. The max value of rand is rand. I mean, you can try this at home. I don't know if that's the. You can try this at home and see. Maybe I will give this instead of this. I'll give you. Um, See what the rand max is on your. So you can run it on Putty and see what you get as the output. Okay. So rand, srand, rand max. That should be clear. Next up is the looping methodology in C++. Now, loops are basic to any language that you work in. I don't recall what kind of a loop it was in BASIC, but you talk about C++, Visual Basic, C Sharp, Java, any language you're using or going to be using is going to have some sort of a loop. C++ in this are three types of loops. One is a while loop, then there is a for loop, and then there is a do while loop. Okay? All three essentially give you the ability to loop with certain condition. Now, in the previous example, I used the for loop, but I'll go back to that. But let me start off with the while loop. The way it works is that's how the syntax is while, and then in parentheses, you give it some sort of a condition. So as long as that condition is true, you're going to stay in the body of the loop. So it starts off, it does a while, looks if the condition is true, and then it comes execute this, and then checks for the condition again. If it's true, do it again. Then checks if it's true, do it again. But if it's false, it exits out of the while loop. And that's how the while loop works. Let me illustrate that with an example here. So in here, I have an example of the number I, which is an integer, which is going to go from 1 all the way to number 5. So what I'm saying here is while I is less than or equal to 5, I output the value of I, followed by a space. Okay, and if you recall this operation from one of the previous reading that you might have done, it's less than or equal to. Okay, so this is the syntax while, and this is my condition. So it's going to start while, look in the condition. If the condition is true, then come in and execute these two statements. Look at it again. If it's true, execute it again. True, execute it again. As soon as it becomes false, it's going to come out of the while loop. Maybe I should have this statement as I am outside the while loop to explicitly make it clear to you guys. So what should happen here? How many times you think you're going to get I? And this is an increment operator. All that does is, and if the book covered it, I plus 1, right? So you can say plus plus I or I equals I plus 1. I did it this way to flip. Hopefully you guys get the syntax. So what should happen is you should go through the loop 5 times and then exit out of there. Let's go ahead and run it, see if that happens. Aha. 1, 2, 3, 4, 5, and I'm outside the while loop. That's how it should be. Make it slightly clear. You see? Hopefully you understand what's going on. I was this while loop, and I less than equal to 5. The first time it was 1, so you saw the output of 1. Then I incremented 1, it's 2. 2 less than greater than less than or equal to 5. 2 is still less than 5. Come in, output 2, then increment I by 1, it's 3. 3 is still less than 5. You output 3, so on and so forth, till you go up till 5. Okay? And then once you're at 5, I equals 5 plus 1, which is 6. 6, is it less than or equal to 5? No. You exit out of the loop. It should be pretty straightforward. If not, like I always say, try it out, play around with it, see what happens. You'll get the hang of it. Okay. Okay, so now we've got the while loop down as I was here. Next up is the for loop. I'll go back to my previous program where I had this for loop. So this is what the syntax of the for loop is. It's the same thing as a while loop, the impact of it, but it's just instead of having the initialization of an integer, the condition, and incrementing of that integer, it's got all three in one line. So here I have an int I that I initialize it to 0, and this is the condition, like we had the condition of the while loop. As long as I is less than 5, I am going to execute the random number, and then I increment 1. 1 to I. I add 1 to I. So that's how I was able to put 5 times this random number. Okay, and then I had an example of, oh, you know what though? Um, there's also another example of while that I forgot to show you. Um, this is an interesting one. Wait, before I go ahead, let me run this program. So this one takes the input from the user and adds all the positive number. So as long as the condition is the while the number is greater or equal to 0, it's going to do this, right? It's going to add a number and then ask for a number and then take in that number and do it over again. So as long as you keep feeding it, giving it positive numbers, it's going to keep adding. The moment it gets a negative number, it's going to stop. It's going to stop. This is an interesting one. So, okay, 1, 2, 3, 4, 5, 6. I'll give it a negative number, -1. So it's going to add all the positive numbers before it. I forgot about this examples. I had this prepared. So once again, I'm gonna run it. 2, 2, 2, -2. So the output should be 6. Right? Okay. So here I have two integers and I initialize the sum to be 0. And as long as the number is greater than or equal to 0, I keep adding it. Sum equals sum plus number. So essentially all this program's doing is adding all the uh, all the positive numbers. Okay, now let's go to the for loop. So while that's the for loop right here. Have this slightly different order. Okay, so this loop is iterated 5 times. Let me run it. I see hello, output it 5 times. Once again, that's the syntax for loop. And in here I have 3 things. It's always 3. The initialization of a value and then a condition. So you check a value against something. So in this case, I less than or equal to 5. Then you increment that value. It's going to come in the first time and output hello. And then I gets incremented. So it's 2. Like 2 is less than or equal to 5. It's less than 5, so it's true. So similar to a while loop, but all these 3 things I've got them in one place instead of multiple places. Okay, let's ahead. That's the do do while loop. There we go. Okay, like I said, try it out, play with it. You'll get the hang of it. This is something very basic that you see in every programming language. Me, I use for the most. I started off with while. You learn the while and the do and the for, but you feel and that you learn once you're comfortable with a syntax, you tend to use it. In my case, it's for loop. Up till this day, I use a for loop. Even when I'm writing code in C sharp, I use a for loop. Doesn't mean while or do are less or nothing great. It's bad, but I just tend to use these. For seems to be my favorite. Okay. The next one is the do while loop. Okay. Do while loop. So the same thing. It'll have a loop in there, and as long as the condition is true, it's going to keep iterating through the loop. So if you recall the previous program you went through, in that I was taking the input from the user, and as long as that input was positive, I keep adding. So the syntax of the do while loop is do, open parentheses, close parentheses, while the statement is true. It's going to keep looping. It's going to keep going in again and again as long as this statement is true. Now I initialized a, in this case, int number equal to 0, int sum equal to 0. Now as long as the number is greater than or equal to 0, I'm gonna be adding that to the sum. This is the same thing as sum equals sum plus the number. Okay, so I start off as 0 equals 0 plus 0 is 0. Hey, please enter a number. I'm gonna take in a number, and I'll see if that number is greater than or equal to 0. If not, I'll stay in the loop. Same thing as the previous loop. Only difference is it's a do while loop, and in the end, I'm gonna output the sum. Let's go ahead and run this. 1, 1, 1, 1, 0, -1. Voila, 4. Let's run it again. 1, 2, 3, 4. It should be 10. There you go. Same thing as the previous program, except it's a do while loop. Okay. Hopefully that was clear and straightforward enough. And play around with all the three loops and see which one is your favorite. Like I said, I tend to use for the most. I like it. It's easy for me to um, use, but that doesn't mean you have to use it. Maybe you like the do while loop more. Uh, but yeah, let me know which one you like, which one you don't like. So that's all I had planned for this session, this lecture. Hopefully those three concepts are clear. Um, if not, feel free to send me an email, or if you want, I can do some sort of a live session and go and walk through with you a program or an exercise to make things clearer. Okay, see you guys next time.